This is the Math 227 S support, statistics with support. We talk about Chapter 9, homework examples. The topic of Chapter 9 is testing the difference between two means, two proportions, and two variances. Chapter 9, formulas. First, z-test for comparing two means for independent populations. Second, t-test for comparing two means for independent populations. Third, t-test for comparing two means from dependent samples. The fourth, z-test for comparing two proportions. The fifth, f-test for comparing two variances. Assumption for the z-test to determine the differences between two means. First of all, both samples are random samples. Second, the samples must be independent of each other. That is, there can be no relationship between the subjects in each sample. The third, the standard deviation of both populations must be known. And if the sample sizes are less than 30, the populations must be normally or approximately normally distributed. First example, a study using two random samples of 35 people. Each found that the average amount of time those in the age group of 26 to 35 years spent per week on leisure activities was 39.6 hours. And those in the age of group 46 to 55 years spent 35.4 hours. Assume that the population standard deviation for those in the first age group found by previous studies is 6.3 hours, and the population standard deviation of those in the second group found by previous studies was 5.8 hours. At alpha equals 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? Solution. Given N1 sample size, N1 is 35 because two random samples of 35 people each. So first group 26 to 35 years, the sample size N1 is 35. Second group is 46 to 55 years old. The age is also 35. N2 is 35. Sample mean. First group, x1 bar is equal average 39.6 hours. Second group, age 46 to 55 years old, spend average 35.4 hours. Population standard deviation for first group, sigma 1 equals 6.3 hours. Sigma 2 from the second group, sigma 2 is 5.8 hours. 5.8 hours. And the alpha is 0.05. And we have to write out the 5 steps for hypothesis testing. First step, state the hypothesis and identify the claim. H0, null hypothesis, H0 is population mean 1 equal population mean 2, mean 1 equal mean 2. And the alternate hypothesis, which is H1, is question asks you, can it be concluded that there is a significant difference? So difference. So the H1 is mean 1 not equal mean 2. Now this is the claim. Identify the claim. H1 is the claim. Step 2, find the critical values for, because it's not equal. It's two-tail test if it put not equal. H1 is not equal, is a two-tail test. So from the t-table, the last row, the degree of freedom is z infinite, and two-tail alpha equals 0.05. Find out critical value. T-table, T distribution T-table. Confidence interval, two-tail alpha is 0.05. Two tails, alpha 0.05. Degree of freedom, so from 0.05 go down to the z, the last row, z, mean degree of freedom is infinite. Find out the critical value, 1.960. And the two-tail, two sides. So this critical value is a positive negative 1.96. Step 3, compute the test value. Use a z-test formula. Z equal x1 mean minus second one sample mean minus population mean minus 1 population mean 2 divided by standard deviation, sigma 1 square plus sigma 2 square, n1 over n2. Plug into this formula. Sample mean 1 is 39.6. Sample mean 2 is 35.4, which is from this given. From this given, x1 39.6, x2 35.4, plug in, minus mean 1 minus mean 2 means they are equal. From null hypothesis, null hypothesis mean 1 equal mean 2, so subtraction is 0. Standard deviation divided by population sigma 1 6.3 square over N1 35 plus sigma 2 population standard deviation 5.8 square over 35. Then the rest use calculator. 39.6 minus 35.4 is 4.2. And this use square root and figure out this is 1.447 divided, got 2.96 is a test value. Then we can draw the graph, draw a line, draw a normal curve. And in the middle is 0. And to the right, critical value 1.96. To the left, critical value negative 1.96. And test value 2.96 is more than 1.96, is to the right of 1.96, is here, 2.96. And this area, alpha is 0.05 divided by 2. So right side, this area is 0.025. And this side is also 0.025. It's two-tailed test. 2.95 is falling in here. Falling in this we call critical region, rejection region. And the twos are rejection region. To the right of 1.96, to the left of negative 1.96 is reject null hypothesis, reject H0. So step 4, make the decision. Because 2.96 greater than 1.96 is 2.96 is falling in rejection region, critical region, also called rejection region. So reject H0, support H1. So step 5, summarize the results. And since the claim is in H1, so this reject H0, support H1, support the claim. So we have said there is sufficient evidence, sample evidence, to support the claim. What is the claim? The claim is, so just copy the question. Question say, claim that there is a significant difference in the average times each group spends on leisure activities. Copy that statement. There is sufficient evidence to support the claim that the means are not equal. That is, the average of the times spent on leisure activities is different for the two groups. Or you can just copy that statement from the question. The second example, a researcher hypothesizes that the average number of supports that college offer for males is greater than the average number of supports that college offer for females. So this is going to be the claim, greater than male, greater than female. A random sample of the number of supports offered by colleges for 50 male and 50 female are collected. The average number of sports for male is 8.6 and the average number of sports for female is 7.9. At alpha is 0.10 level of significance. Is there enough evidence to support the claim? The claim is here. that the average number of spots that college offer for males is greater than the average number of spots that the college offer for female. Assume population standard deviation sigma 1 and sigma 2 both are 3.3 are given. So is a population standard deviation is given, use the Z test. So solution, given sample size N1 50 female, N2 50 male, 50 female, so N2 is 50. Sample from 50 males, average for the male is 8.6, so X1 bar is 8.6. Sample X2 bar is 7.9. And the population standard deviation, sigma 1 equals 3.3, sigma 2 equals 3.3. Alpha is 0.10. First step, state the hypothesis and identify the claim. So it's going to always the null hypothesis H0 is equal, mean equal. Alternate hypothesis H1, here want to be male greater than female. Male is mean 1, mu1 greater than mu2, female population mean, and indicate this is the claim. Step 2, find the critical value for this greater than point to the right, greater than this pointer point to the right. So it's a right tail test. Right tail test. The alpha is 0.10, is totally to the right. Do not divide it by 2. So it's the total alpha to the right tail. And find critical value for the right tail test. From T table, the last row, degree of freedom is infinite for the Z. Since alpha is 0.10, one tail test. So this one tail test, right tail test is one tail. Alpha equals 0.10. Go down to the bottom of the table, the last row, Z, degree of freedom, for the Z, degree of freedom is infinite, is 1.282. So that's the critical value, positive on the right. So it's 1.282. Compute the test value, Z test value, use the formula. X1 bar is 8.6. X2 bar, sample, second one is 7.9 minus mean 1 minus mean 2 from null hypothesis, they are equal, so subtraction is 0. Square root, population standard deviation 3.3 square over N1 50 plus sigma 2 3.3 square over 50, and use calculator and figure out the test value is 1.06. Then 1.06 is less than 1.282. So it's to the left of critical value. So this test value is not falling in rejection region, which is do not reject H0. To the right of 1.282 is rejection region, critical region, reject H0. To the left of critical value 1.282 is fail to reject H0, so fail, make a decision, fail to reject the null hypothesis. And summarize, step 5, summarize the results. So we have to, because claim is H1, so we have to summarize the results. We have to conclude with the claim. Since it is do not reject H0, so we will say there is not sufficient evidence to support the claim. Claim is H1. That what? Then copy this statement, the question from the question, that the college offer more sports for male than they do for females at the 0.10 level of significance. You can just copy this statement. There is not sufficient evidence to claim that the average number of sports that colleges offer for males is greater than the average number of sports that college offer for female. Now, just copy that statement down. The next one, we talk about t-test. For the t-test, assumption for the t-test for two independent means when population standard deviation 1 and the population standard deviation 2 are unknown. If unknown population standard deviation are unknown, use t-test. If a given population standard deviation, sigma 1 and sigma 2, if given, and use z-test like first and the second example. If unknown, use t-test. First assumption, the samples are random samples. Second, the sample data is independent of one another. The third, when the sample size are less than 30, the populations must be normally or approximately normally distributed. So questions, example 3. A researcher wishes to see if the average weights of newborn male infants are different from the average weights of newborn female infants. Difference, not equal. So this is the claim. She selects a random sample of 10 male infants. So N1 is 10 male infants, N1, and finds the mean weight is 7 pounds 11 ounce. So X1 bar sample mean is 7 pounds 11 ounce. And the standard deviation, so S1, sample standard deviation S1 is 8 ounce. She selects a random sample of 8 female, so N2 is 8 female infants, and finds that the mean weight is 7 pounds 4 ounce. So X2 bar sample mean is 7 pounds 4 ounce. And the standard deviation of the sample, so S2 is 5 ounce. S2 is 5. Can it be concluded that alpha is 0.05, that the mean weight of male infant is different from, so this is the claim, the mean weight of male infant is different from, so it's not equal from the mean weight of female infants. Assume that the variables are normally distributed. So first, step 1, state the hypothesis and identify the claim. So null hypothesis is population mean are equal. Alternate hypothesis H1 is population mean are not equal, and this is the claim. Step 2, find the critical values. Since the test is not here, null hypothesis is not equal, is a two-tail test. And alpha equals 0.05. The degree of freedom are the smaller of n1 minus 1 or n2 minus 1. In this case, n1 is 10. 10 minus 1 is 9. n2 is 8. 8 minus 1 is 7. So 9 and 7, the smaller one is 7. So from T table on row, degree of freedom is 7. Find the critical values. From T table, T distribution table, two-tail, alpha equals 0.05. Two-tail, alpha equals 0.05. Degree of freedom is 7. 2.365. Two-tail, 0.05. And the degree of freedom is 7. Get this number, 2.365. Positive and negative because two-tail. Compute the test values. Change the means to ounces. 1 pound equals 16 ounces. So X1 bar is 7 pound 11 ounce. 7 pound times 16 ounce per pound, 16 ounce plus 11 ounce. So X1 bar is 123 ounce. X2 bar is 7 pound 4 ounce. 7 times 16 plus 4 is 116 ounce. And plug into t-test formula. So T equal to X1 bar is 123 minus X2 bar is 116 minus mean 1 equal mean 2 is 0. Subtraction is 0. Standard deviation, sample standard deviation 8 square over 10 plus S2 is a 5 square over 8. And figure out is 2.268. And this is a two-tail test, the normal curve. The critical value is a positive, negative, 2.365. Alpha is 0.05 divided by 2, so each tail is 0.025, each tail. So the two are critical values. And the test value is 2.268. 2.268 is less than 2.365. So it's to the left of 2.365, less than. So it's falling in here. So it's falling in H0. So it's not fall in critical region. So it's a non-critical region. So this is suppose H0. So it's a fail to reject. Make the decision. So between it is H0. The two sides is H1. So this is a fail to reject null hypothesis H0 at alpha equals 0.05. Summarize the results. When we summarize the result, we have to stick with the claim. The claim is H1. So since this one is a fail to reject as H0, so it's not support the H1. So there is not sufficient evidence to support the claim that copy the statement done. that here that the mean weight of the male infant is different from the mean weight of female infants. Then next example. The mean age of a random sample of 25 people, so N1 is 25, who were playing the slot machine is 48.7 years. So X1 sample mean, X1 bar is 48.7. And the standard deviation, so S1 is 6.8 years. The mean age of a random sample of 35, so N2 equals 35 people, who were playing roulette is 55.3 years. So X2 bar is 55.3 with a standard deviation, so S2 is 3.2 years. Can it be concluded that alpha is 0.05? Claim is what? That the mean age of those playing the slot machine is less than those playing roulette. So first step, state the hypothesis and identify the claim. Null hypothesis H0 is mean are equal. Alternate hypothesis H1 is less than, so population mean 1 less than population mean 2. This is the claim. Here say less than. So this is the claim. Step 2, find the critical values. Since this is less than, this point to the left. So this is the left tail test. So alpha is 0.05. So alpha 0.05 totally given to the left tail. The degree of freedom are the smaller between N1 minus 1 and N2 minus 1. N1 is 25, minus 1 is 24. N2 is 35, minus 1 is 34. So compare 24 and 34. The last one, degree of freedom, use 24. So from T distribution table, degree of freedom, 24. Left tail test, alpha 0.05. One tail test, 0.05. Go down from 0.05. One tail, alpha 0.05. Go down to degree of freedom, 24. Degree of freedom, 24. One tail, alpha 0.05. Degree of freedom, 24. And get this number. This is a critical value, 1.711. And since left, so it's negative. Put the negative because the left side, negative 1.711. And compute the step 3, test value. Use the formula, x1 bar 48.7 minus x2 bar 55.3 minus the mean 1 equal population mean equal. So subtraction is 0. Then square root S1 6.8 squared over N1 25 plus S2 3.2 squared over N2 35. Then figure out it's negative 4.5094. Then this is a left tail. Critical value is a negative 1.711. And the negative 4.5094 is less than negative 1.711, is to the left of negative 1.711. So this one is we call critical region or rejection region. So this test value negative 4.5094 is falling in rejection region. We reject H0. So make the decision, reject the H0. Since we reject H0, that means we reject H0. So it's support H1. So we say there is a significant sample evidence to support the claim. And what's the claim? That the mean age of those playing the slot machine is less than those playing roulette. Just copy this statement done. So next one we are going to learn is two means when the sample are dependent. Use the t-test for two means when sample are dependent. And the question 1, 2, 3, 4, they are independent. Sample are independent. And the question 5 is the sample are dependent. Assumption: first, sample or samples are random sample. Second one, sample data are dependent. The third one, when the sample size or sample size are less than 30, the population or populations must be normally or approximately normally distributed. Example 5. A random sample of 9. So, 9 local banks, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 local banks show their deposit in billions of dollars. 3 years ago, here's 3 years ago, Bank 1 deposit is $11.42 billion. Bank 2, 3 years ago, deposit is $8.41 billion, and etc. This out. And their deposit in billions of dollars today. Here's today. Bank 1 is $16.69 billion. Bank 2, Bank 3, and etc. At alpha equals 0.05, can it be concluded that the average in deposits for the banks is greater today than it was 3 years ago? Use alpha equals 0.05. Assume the variable is normally distributed. Solution. First step. State the hypothesis and identify the claim. Since we are interested in to see if there has been an increase in deposit. Here say, can it conclude that the average in deposit for the banks is greater today than it was 3 years ago? So that means increase today. So if there has been an increase in deposit, the deposits 3 years ago must be less than the deposit today. Hence, the deposit must be significantly less 3 years ago than they are today. Hence, the mean of the difference must be less than 0. The 3 years ago minus today is negative, because 3 years ago is less than today. So 3 years ago deposit less than today. So subtraction is mean of the difference is less than 0. So null hypothesis is mean of the difference, the two difference, average, figure out difference and figure out average is 0. And alternate hypothesis is mean of the difference is less than 0 is the claim. Find the critical values. The degree of freedom is n-1. Here n is 9 banks, so 9 minus 1, degree of freedom is 8. From T table, the row with degree of freedom 8, the critical value for the left tail test, because this is a less than, this pointer point to the left. So this left tail test is one tail test. So you, from T table, 0.05 alpha is alpha is 0.05, one tail. So you look at one tail, 0.05. Degree of freedom is 8. 9 minus 1 is 8. So one tail, 0.05. Degree of freedom, 8. Get critical value, 1.860. Since the left, so use negative. So it's a negative 1.860. And step 3, compute the test value. The test value, we make a table. Because we are going to use test value. We are going to use this formula. T equal D bar, difference of the mean minus mean difference, population difference. Mean. SD is a difference of standard deviation over square root of n. N is 9. So here we need to figure out D bar. And the mean difference is 0. Mean difference is 0 here. Null hypothesis, mean difference is 0. And we are alternate hypothesis, difference, population difference of the mean is less than 0. So we need to, this difference, population difference, mean is 0. So we need to figure out the sample difference, average, mean, sample mean of difference. And we need to figure out standard deviation difference, standard deviation, SD. So we make a table. First of all, we have to find out D difference between x1 and x2. And then add together, get sum of the difference. And find the mean, sum of difference divided by n, we got D bar, that's the mean. So 3 years ago is x1, those are the deposit 3 years ago for the 9 banks. And today, x2 deposit for the 9 banks is so much $billion. First of all, figure out difference between x1 and x2. So x1 minus x2. So 11.42 minus 16.96 equal negative 5.27. 8.41 minus 9.44 get negative 1.03. And keep going on. 1.35 minus 1.22 get positive 0.13. Then you add together is a summation of difference is a negative 9.73. Then negative 9.73 divided by n9 and get mean of difference, negative 1.081. Then you can plug it into here. Mean difference is negative 1.081 into this formula. In this formula, we have to find out SD. SD is this formula. N is 9, and summation of d squared. So we need to figure out summation d squared. Summation of d already figured out, and this. So then we figure out d squared. So this negative 5.27, this column square. Negative 527 squared, get 27.7729. Negative 1.03 squared, get 1.0609, and etc. 0.13 squared, get 0.0169. And those 9 data add together is the summation d squared is 40.5437. Then we plug into this standard deviation of the difference formula SD equal n is 9. Summation of d squared is 40.5437 minus summation of d difference is negative 9.73 squared over n is 9. 9 minus 1. Then figure out, use calculator, figure out is SD is 1.937. Then plug into test value t equal mean of difference minus mu d over standard deviation over square root of n. This difference of mean of the difference is negative 1.081 minus 0 and 1.937 over square root of n is 9.